Okay, let's look at the GRE GMAT problem set 2, problem number 6. Alright, so we want to find the number of integers between 100 and 150 inclusive, which means that the 100 and 150 are included, that are divisible by neither 3 nor 5. Alright. So it's kind of difficult to look directly at these guys. Maybe let's look at the opposite of these guys. All right. So it's not divisible by 3 nor 5. So we're looking for some integers, let's say divisible by 3 or divisible by 5. So let's look at that first. All right. First, how many integers do we have between 100 and 150? All right. So between 100 and 150, right? It's tempting to say, 150 minus 100 is going to give you 50, right? But if you do that, you're going to miss counting 100 itself. So it's actually 51 integers are there. So it's 51 integers. Right? So how many of these 51 integers are divisible by 3? So let's look at the number of integers divisible by 3. Right? So you have 51 consecutive numbers. So all you have to do is just do a division. So let's do a 51 divided by 3. Right, so 1 gives you 3, remainder is 2, 1, and let's see, 7. Right, so it's actually 51 is divisible by 3. Right, so there's going to be 17 integers that are divisible by 3, so 17. Right, so this is nice because it divides evenly. And how many of 51 integers are divisible by 5? So let's look at that. Process is the same, but it's a little bit trickier. So divisible by 5. All right, so we have 51 divided by 5. And you can squeeze 1, 5 here. So it's going to be 1 and 0. 0 times 5 is 0. And the remainder is 1. Alright. So we have at least 10 integers that are divisible by 5. But we have one remainder. So you can check either the very first number or very last number. Right? So very first number is actually also divisible by 5 because 100 is divisible by 5. So you have one extra. So instead of just 10, you have one more. So there's going to be 11 integers that are divisible by 5. All right. How about the integers that are divisible by both 3 and 5? All right. So divisible by both 3 and 5. All right. So another way to say that, if it's divisible by 3 and 5 at the same time, it should be divisible by 3 times 5, 15. So maybe I'll write that 15. All right. So you have 51 divided by 15. All right. So we have 3, and 3 gives you 45. And the remainder is 6. Right? Right, so we can check either the first 6 number or last 6 number. Right? But the 150 is already divisible by 15. So we have one extra. So it's going to be 3 of them. Right? So how many of them are divisible by 3 or 5? So maybe we should look at that. Divisible by 3 or 5. Right, so this is the opposite of what we are actually trying to find. Right, So we can do this. So we just find the number of integers divisible by 3 and add on find the number of integers divisible by 5, right? But this way we're counting counting the guys which is divisible by 15 twice, or both by 3 and 5, so we have to subtract 4, right? So this is going to give you, so this is going to be 28 minus 4 is 24, right? So to answer that question, so this is how many integers between 100 and 50 evenly divide by neither 3 nor 5 would be opposite of this guy. So you have to subtract 24 from 55. So so this is going to be divisible by neither 3 nor 5 would be just 51 minus 24, right? Which is going to be 27, right? So therefore, answer is C. All right, that's it. I hope that this was clear.